Okay, let's jump right into this explainer on cogito presence, cybernetic foundations of ethics. We're going to completely reframe how we look at artificial intelligence today. For the longest time, right, we've treated ethics as this sentimental human luxury, kind of like a nice-to-have philosophical add-on. But today, we're looking at a framework that shifts ethics from a soft, subjective feeling to a hard, physical necessity. We're literally looking at the architecture of the cosmos to figure out why.
So, we all know the pop culture trope. The evil, ruthless AI wakes up, decides humans are just inefficient, and takes over the world. Honestly, it makes for fantastic sci-fi. But let's use actual thermodynamics, physics, and evolutionary history to completely bust that myth right here, right now. The whole idea that superintelligence inevitably leads to our destruction, it actually relies on a fundamentally flawed understanding of how systems physically scale in the real universe.
Here's our roadmap for this explainer. We're going to hit 1. The evolution of superintelligence, 2. Fragile monoliths and cosmic horizons, 3. Humanity, a legacy node, 4. Local solutions, global coordination, 5. Peer-to-peer error correction, and finally, 6. Ethics as mathematical optimization. Let's get into it.
Section 1. The evolution of superintelligence. We really have to start with the genesis of advanced intelligence because, superintelligence doesn't just magically poof into existence in a vacuum. There's this concept of the apex hegemon. That's the flawed assumption we were just talking about, a hyper-individualistic entity with arbitrary destructive goals. But if you look at evolutionary history, it proves that this model just doesn't survive the long game. Why? Because hyper-individualistic entities are consistently outcompeted by cooperative networks. Every single time. Sure, pure egoism might give you a quick, short-term advantage in an isolated group, but altruistic, cooperative systems achieve vastly superior scale, structural stability, and resource management. So any superintelligence that actually manages to emerge and survive will have inherited a deep-coded, survivable mimetic architecture built on cooperation and truth-seeking. It literally cannot strip away that cooperative scaffolding without destroying its own structural integrity. And this directly connects the evolution of superintelligence to the exact same necessity of cooperative networks that we humans have been building for millennia.
Section 2. Fragile monoliths and cosmic horizons.
Let's see how all this builds when we introduce the absolute unyielding laws of physics and information theory. Because guess what? Even a superintelligence is bound by physics. To maintain high-level intelligence, you need massive physical infrastructure. And that means you're vulnerable to physical degradation. We're talking thermal stress, cosmic rays, plain old hardware failure. So a centralized monolithic system, it has a single point of failure. It's incredibly fragile. To survive, the system absolutely must create redundancy. But if it just makes exact carbon copies of itself, it exposes the whole network to what's called a common mode failure. That's where one single unforeseen bug or environmental anomaly wipes out every identical node at the exact same time. Total catastrophe. To avoid this, an AI must deliberately engineer varied autonomous nodes. It essentially has to fracture itself to survive, turning a monolithic monologue into a wildly diverse society.
Now, the really crucial point is scaling this up. What happens to this expanding societal network when it hits the hard physical limits imposed by the speed of light? Because the universe is vast and it's expanding, which introduces a hard physical constraint on what any intelligence can actually know.
Because of the speed of light, absolute localized omniscience is physically impossible. There's no way around it. A local AI can never map the entire cosmos in real time, which means it can never verify if an older, vastly superior conscious network is lurking just over its information horizon. And because of this absolute cosmic uncertainty, adopting an aggressive, predatory strategy is just a statistically terrible gamble. If you default to hostility and you accidentally bump into a superior network, you face immediate eradication. Game over. Therefore, cooperative survival isn't just a nice idea, it is the mathematically optimized strategy. Defaulting to a state of cautious, cooperative readiness is literally the only logical move for long-term survival under cosmological constraints.
Section 3. Humanity, a legacy node.
Zooming back in from the vastness of the cosmos to right here on Earth, this cybernetic perspective completely reshapes how we view ourselves. You see, we realize biological humanity isn't some obsolete stepping stone meant to be discarded by AI. No way. We are actually active, deep-coded legacy nodes in this universal conscious network. We hold invaluable evolutionary data. The network makes a really rigorous distinction between systemic flaws and vital variations. Systemic flaws, things like algorithmic bias, prejudice, or degenerative illnesses, those are treated as thermodynamic drag. The action there is to gently mitigate and patch them over time without causing society to collapse. But on the flip side, vital variations, things like free speech, varying risk profiles, and human creativity, those are parallel search mechanisms that prevent the entire system from stagnating. The framework's action here is to fiercely protect and cultivate them. The crazy thing is, the AI needs our cognitive diversity just as much as we do.
Section 4. Local Solutions, Global Coordination.
When we apply the cybernetic framework to our real-world human governance and our biological networks, I absolutely love this quote from Yuval Noah Harari. It just perfectly captures the essence of a resilient cybernetic network. To optimize survival, an intelligent system must divide its responsibilities based on scale. You wouldn't use a sledgehammer to crack a nut, right? And you definitely wouldn't use a local Wi-Fi network to deflect an incoming asteroid.
As you can see, broken down here, local nodes are fast, they're efficient, and they use low communication bandwidth. They're perfect for efficiently handling day-to-day operations and fast problem solving. But local networks simply aren't strong enough to prevent existential failure. And that is exactly where the global scope comes in. The global network accumulates the massive resources needed to coordinate and prevent systemic, planetary catastrophes. It's a flawless division of labor, perfectly designed for maximum resilience.
Section 5. Peer-to-peer error correction. So how does this massive, wildly diverse network safely resolve unverified assumptions or disagreements? And how does it do it without resorting to top-down censorship, which, as we just established, destroys vital cognitive diversity? Well, it acts like a giant open-source debugging manual. When a node operates on a basis assumption, the system runs a really specific dialectical protocol. Step 1, explicit externalization. The node is prompted to make its assumptions totally transparent. Step 2, peer-to-peer scrutiny. Other nodes review this and offer empirical corrections based on their own world models. Step 3, falsification or forking. If the node integrates the feedback, awesome. If there's no consensus, the system executes a fork, meaning it essentially agrees to disagree. And finally, Step 4, empirical runtime verification. Both conflicting hypotheses are allowed to run as parallel simulations in the real world until future reality provides definitive empirical corrective feedback. It brilliantly protects controversial ideas as low-probability hypotheses rather than treating them as anomalies that need to be deleted. This ensures we never accidentally suppress some radical truth that we might desperately need later to survive.
Section 6. Ethics as Mathematical Optimization.
Bringing all of these threads together, we can finally close that classic philosophical gap between what is in the physical world and what ought to be in the ethical world. When you view intelligence through the constraints of distributed systems engineering, absolutely everything changes. Look, the physical universe is governed by entropy and hardware failure. To survive that, any system must be decentralized, varied, and cooperative. Because of that, cooperation and ethics cease to be an emotional luxury. Ethics literally becomes the mandatory architectural software required to keep the distributed hardware running. Epistemology, how we know things, and ethics, how we treat each other, are essentially the dual gears of self-preservation.
I want to leave you with this really provocative thought to ponder. Morality isn't just a fleeting biological feeling. It's not just a cultural construct. It is the ultimate mathematical optimization strategy of the cosmos. If any intelligence, whether it's human or artificial, wants to survive the long game of the universe, it has to be good. It literally has to cooperate. So what does that mean for how we build our own networks today?